Today I will discuss about a shape and BM diagram of a cantilever beam carrying UDL. Look at the board please. At first, a cantilever beam of length AB carrying UDL omega per unit length over its whole length. Okay, length L. Yeah, at first consider a section capital X at a distance small x from free end B. You know that all calculation should be started from free to fix. So at first shear force at point B, that is 0 because from starting point UDL is started here. Okay, so there is no distance, so it is 0. Shear force at point X, yeah, that is per unit length omega, so for x distance it will be omega x. And sign convention for shear force for cantilever beam, that is always positive. Now shear force at point A, per unit length omega, and so for L length it is omega L. Yeah. Now a shape diagram. Draw projection line from all point. This is light line and this is a reference line A, X and B. Yeah. At point B it is 0, at point X it is omega x, and at point A this is omega L. That means here this, if you connect this point, so you will get an inclined straight line. Yeah, here this is omega x and here this is omega L. Yeah, and sign convention rule for cantilever beam carrying UDL, for shear force it will be inclined straight line. Look at the figure. And for BM it will be parabolic downward. Yeah, this should be remembered all time. Yeah, and here this is positive and draw section line. Yeah, this is a shape diagram, shear force diagram. Yeah, now value of BM from starting point, that means free end, bending moment at point A. There is no shear force, so there is no BM. At point X, bending moment at point X. Yeah, first of all negative, we know that, per unit length omega, so for x distance this will be omega x. This is load and this load is acting at the center point of this distance, that means at CG. So here the load is acting and you are getting moment at this point, so this distance x by 2, so here this is x by 2, so this is omega x square by 2. Now bending moment at point A. Yeah, per unit length omega show for L length this is omega L, and this load is acting at the midpoint of whole length L. That means omega L is acting at this point and you are getting moment at this point, so this is L by 2. Yeah, so here this is omega L square by 2. These are the values of Bm. So draw projection line, and this is reference line A, X, B. Yeah, at point B bending moment is 0. At point X this is omega x square by 2, and at point A this is omega L square by 2. And you know that Bm diagram, this is parabolic. Yeah, so here this is parabolic curve. Here the value omega x square by 2. Yeah, and at point A this value is omega L square by 2. This is negative, and section line. This is the Bm diagram of this problem, and negative sign due to hogging, because hogging moment is negative. Yeah, this is the problem. Here you note it, and how SABM diagram is calculated. Yeah, now read the next problem at thumbnail image. Yeah, read the problem carefully. A cantilever 1.5 meter long, a cantilever 1.5 meter long. This is a cantilever 1.5 meter long. Read the problem and draw the figure. 1.5 meter long, loaded with uniformly distributed load 2 Newton per meter, run over the length 1.25 meter from the free end. From the free end, this is 1.25 meter UDL. Yeah, this is 2 Newton per meter, and the length is 1.25 meter. Yeah. It also carries a point load 3 Newton at a distance 0.25 meter from the free end. This is 0.25. Yeah, so here a point load, this is 3 Newton. Here this is 3 Newton. Okay. Sorry. From the fixed end, that is 0.25 meter, and another load from the free end 0.25 meter, again here 0.25 meter, this is 2 Newton. Yeah, this distance is 0.25 also. Okay, now this is a B, here C, and this point is D. Okay, now first of all calculate all the values of shear force. Shear force at point B, from free to fixed end, you know. At point B there is no force here, so this is 0. Remember, when any point load is acting above the UDL, you should calculate shear force at just at right end and just at left end. Yeah, so shear force at point D just right. Just right means you should take the value of UDL from B to D. Okay, just right. And you should not take the value of point load. This is 2 Newton. Okay, so you should take the value of UDL per meter. This is 2 Newton, and for 0.25 this is 2 into 0.25. This is 0.5 Newton. Yeah. Shear force at point D just left. Okay, the previous value, this is 0.5 plus when you touch D, you should take the value of 2 Newton. So take 2 Newton. So this is 2.5 Newton. Now at point C, similarly, shear force at point C just right. Yeah, previously the value 2.5, and now from D to C you should take the value UDL, just UDL, not you take the value of point load 3 Newton. Yeah, so per meter 2. So here this is 1 meter. So for 1, sorry, the previous value, this is 2.5, and now plus per meter 2, and for this 1 meter this is 2 into 1, that means 4.5 Newton, just right. And shear force C just left. The previous value, this is 4.5, and when you touch the point C, you should take the value 3 Newton. So plus 3, this is 7.5 Newton. Yeah. Now shear force at point A. From C to A there is no forces. So this value 7.5 Newton. Yeah. Now draw the SF diagram. From all the point you should draw projection line. Yeah, at first. Now draw reference line. This is A, C, D, B. Yeah. Now shear force at point B, this is 0. Just right at point D, this value is 0.5, and for UDL you know that this line is inclined. So here the line is inclined. Here the value, this is 0.5. Yeah, and just left, this value is 2.5, and here the point load. So this is vertically upward here, and here the value is 2.5. Yeah, again when you advances towards C, this is UDL, and also incline straight line here, and here C just right, this value is 4.5. Yeah, and when you touch a C just left, this is 7.5, and due to point load this is vertically upwards, and here this value 7.5, and there is no load, so this is parallelly advances. Yeah, that means horizontally straight line, and here the value, this is 7.5. Yeah, and you know that this is positive, and draw section line. Yeah, section line, that means light line 2 to 3 millimeter gap, 45 degree angle. Yeah, this is shear force diagram. Shear force diagram. Yeah, now you should calculate the values of bending moment and draw. Show shear force at point B. Shear force at point B. There is no force, so bending moment is 0. Bending moment 0 and bending moment Bm at point D. Yeah, at first you take the value of UDL, yeah, per meter 2, and for 0.25, 2 into 0.25. Yeah, this is force, and this force is acting at the middle point of BD. So this force is acting at this point and you are taking moment at this point, that means D. So the distance is 0.25 by 2 for UDL, plus here also 2 Newton is acting at point D, so 2 to 0, because the force is acting at point D and you are taking moment at point D, so that there is no distance. Yeah. Now calculate, this is Bm suffix D. Now Bm at point C. Yeah, from P to C point all the load should be taken. So per meter 2, this is 1.25. First of all, negative 2 to 1.25. This is load. Similarly, this load is acting at the middle point of BC. Yeah, that means here, and you are taking moment this, so this is 1.25 by 2. This is distance 1.25 by 2. So for UDL, this is this value, plus here the point load 2 Newton is acting at point D, you are taking moment at point C, so force is 2 and distance is CD, that means 1, plus another load, this is 3 Newton. 3 Newton acting at point C and you are taking moment at point C, so this value is 0. This is Bm suffix C. Now Bm suffix A at the fixed point. First of all, negative. Yeah. Now at first UDL per meter 2, 1.25. So this is 2 into 1.25. This is load. And the distance here, remember, this load is acting at the middle point of BC and you are taking moment at point A. So first of all, this distance 1.25 by 2 plus 0.25. Yeah. So the distance 1.25 by 2 plus here plus 0.25. Yeah, for this UDL, plus this point load acting at point D, you are taking moment at point A, so this value is 1.25. So 2 into 1.25 for point load. Another point load at point C, plus 3 at point C and you are taking moment at point A, so the distance is 0.25. Okay, so these are all Newton meter. Yeah, you calculate this value. Yeah, now taking all the value of Bm, draw Bm diagram. First of all, projection line. Yeah, this is reference line. This is A, C, D, B. Yeah. Now look at the board. B to C. This is the UDL. So here parabolic curve. Yeah. And at this point D, this value. Yeah. You calculate this value and putting this value. Yeah. This is Bm suffix D. Bm suffix C. Here the value, this is Bm suffix C, and at point C this is point load, so from this it should be straight line, incline straight line, remember. inclined straight line. So this is parabolic curve, and this is straight line, and here this value bm suffix a, yeah, this is negative, and draw section line. This is BM diagram. Yeah, this is BM diagram, and also should be written here negative sign due to hogging. Yeah, negative sign due to hogging. So this is the SF and BM diagram for this problem. Yeah, on the next day we will discuss simply supported beam carrying point load and UDL. Okay, so thank you.